Hello everyone, welcome back to my channel. My name is Ananya P. Tamkar and I am a student from Sri Venkateswara College of Engineering. In this video, I shall talk about animation with physics. Don't forget to like the video and subscribe. Without further ado, let us begin. What is animation? The animation is the technique of photographing successive drawings or positions of puppets or models to create an illusion of movement when the film is shown as a sequence. One drawing or photo in an animation is called a frame. The arrangement of frames in a sequence is called timeline. Animation usually consists of 24 frames per second and may vary from 12 to 30 frames per second. I shall now discuss the different types of animation. Traditional animation is hand-drawn. It's how they made classic films like Snow White and the Seven Dwarfs and Sleeping Beauty. Each animated component is painted on a separate layer of transparent sheets, so they can be animated separately. 2D animation. 2D animation is the art of creating movement by combining a sequence of images together in a two-dimensional space. 1 second of animation is equal to 24 pictures, but most 2D animation usually only animates every second frame. It's enough to create the illusion of movement without needing to animate all 24 frames. 3D animation. 3D animation is the art of bringing digital characters, vehicles, props, and full scenes to life in a virtual 3D space. It's more mechanical and technical than 2D animations and requires input from other departments to create 3D models and complete character rigs. Another important distinction between 2D and 3D animation is that with 2D, you only create one side of the character, while in 3D animation, the character rig is designed completely. Motion capture. Motion capture helps enhance the realism of 3D animations. It's used in movies like Avatar and Lord of the Rings and video games. Actors wear bodysuits containing special sensors and act out a scene. The motion capture animation software translates the motion from the sensors into a digital version. Motion graphics. It is the animation that allows you to animate text, logos, and basic illustrations. They're commonly seen in animated logos, opening and closing film, and TV credits explainer videos. And the graphics you see on top of sports plays on TV. Stop motion animation. Stop motion is a series of still images filmed or shot sequentially to simulate action. It's how movies like Nightmare Before Christmas and Corpse Bride are made. You can create this animation style with real actors, clay figurines, or even toys and other props. Why physics in animation? One of the trends in visual media is an ever-increasing demand for realism and graphical fidelity. This is most visible in live-action works. Live-action media is realistic by default, so when visual effects are used in live-action work, these effects too have to be realistic so they won't look out of place. In addition to image rendering, physics is widely used to make things move in animation. Some elements in animation cannot be animated manually, such as hair and fur, movement of liquids, free-falling objects, gases from an explosion, etc. To animate these elements, simulations are used. These simulations apply basic laws of physics to objects that need to be animated. Let us talk about a few simulations. Basic rigid body simulation. It is the most simple and oldest simulation. It applies basic laws of physics such as gravity and friction. It does not require overly complex calculations. Here we have basic geometric shapes to which some basic laws of physics, primarily gravity and friction, are applied. Scenes like these were first introduced in pre-rendered works like commercial, movies, and TV shows. Next, we have fluid dynamics. Animation of fluids can be difficult to animate manually, hence physical simulations are used. They are advanced physical simulations and requires a lot of processing power. A large number of physical bodies are used to approximate the movement of a body of water. Physics and characters. Historically, the first attempt to combine character animation and physics was the so-called Ragdoll physics. The idea here is similar to the simple rigid body physics we've already seen. Several geometric shapes are linked together to roughly approximate the character's body. Simulation is then run for this body to calculate how the character would move in free fall. Here we can see a ragdoll falling. This is under a physical simulation. Fun fact: did you know that in movies like Tangled and Monster Incorporation, animators developed a separate program to simulate the movement of fur? These simulations were applied to Rapunzel's hair and the furs on monsters to make the hair and fur look more realistic, bringing a more dynamic feel to the movies. I hope you found this video informative and learned something new. Have a nice day and thank you for watching.